All right, eighth graders, we're into the third chapter that we're doing for distance learning, and we are on to chapter 18, which is about Earth's natural resources. We're gonna kind of scoot through this one kind of fast. So if I'm going too fast, just take the time to pause it and make sure you get the notes, okay? All right, so we're talking about Earth's natural resources. And the first section, 18.1, is about energy resources. This is where we're talking mostly about fossil fuels, okay? So we've got a couple different types of resources. They're categorized in two different types. The first one is the non-renewable resources. These are resources that get used faster than they can be replaced by some natural process, okay? So when we think about non-renewable resources, we're thinking about coal, oil, natural gas, uranium. You know, we use uranium for nuclear power reactors, also to make big bombs and things like that. But that stuff doesn't renew itself very quickly on our planet. In fact, it takes hundreds of millions of years, depending on the conditions on Earth, right? So those would be considered non-renewable because they can't be replaced very quickly by natural processes. Renewable resources are ones that can be replaced by a natural process in a very short amount of time or relatively quickly. And when we think about renewable resources, we think mainly solar, wind, geothermal, hydroelectric would probably be another one. These are ones, like, if you think about it, the sun doesn't shine every single day. And if your house is powered by solar power, or you have a solar power, whatever it happens to be, it may not work that great, and you may not be able to produce very much electricity when the sun isn't shining. But realistically, it's unusual that the sun is not going to shine. And, you know, the sun is estimated to burn out in about 4.5 billion years. So the sun is shining every single day. It's just, the problem is that sometimes it's not shining directly on the spot that needs the sunlight to create energy, right? Like at nighttime, the sun still shines at night. It just shines on a different part of the Earth. Wind is another renewable resource. Almost always there's wind blowing. There might be days where it's a little more calm than others, but generally speaking, the wind is something that can produce electricity on a fairly consistent basis. And then finally, geothermal. Geothermal is always happening because the interior of the Earth is relatively hot. And the closer you get to the core of the Earth, the hotter and hotter it is. It's thousands of degrees. We'll talk about each of those in a little more detail. Fossil fuels, now this is non-renewable, coal, oil, natural gas. Those are formed over millions and millions of years from the remains of prehistoric organisms that have been decaying away for millions of years, okay? We think about things like tropical rainforests and a lot of ferns that grow, and that stuff eventually gets covered up by more and more and more layers as it dies. And then over long periods of time, and with temperature, if the temperature and the pressure is correct, it will form things like coal, for example. So obviously that's probably not going to happen very quickly, or even over the course of hundreds and hundreds of years, this wouldn't happen. Okay, so the type of fossil fuel depends on the type of organic material that has decomposed. In all conditions, it takes temperature and pressure and usually lengthy amounts of time where that organic material was buried. Okay, so here's kind of how it works. We're looking at an ocean or a body of water. Things die, they fall into the water, and they settle down to the bottom of the water. Over time, sediment covers that material, trees, animals, whatever it happens to be. Mostly we're talking about like plant life. And it gets covered and covered and covered by sediment, and then over time, heat and pressure compress that, and it turns it into our fossil fuels: coal, oil, natural gas. Now, coal formed mostly from ferns and trees in these swamps that were present 300 million years ago, in like prehistoric swamps. Again, kind of the same process happened. We have that really thick layer of dead ferns and plants, and it gets covered up by sediment, and then maybe an ocean fills in that area. It creates this area where there's a tremendous amount of pressure, and that, along with the heat from the earth, turns that into a coal bed. Oil and natural gas, they form also millions of years ago, and they form from the microscopic remains of plankton. Okay, so these little marine organisms, as they're floating around on the surface of the ocean, as they die, they sink down to the bottom, and as that, there's bacteria down there that helps to decompose that organic material, and if the temperature and pressure gets high enough, it can form natural gas, and it can create these areas inside oil wells where natural gas collects as well. So fossil fuels are responsible for storing a lot of energy. If we think about the amount of energy it would take to push a car, even just 100 yards, like if I said, hey, I want you to push this car from here to there, and it's 100 yards, excuse me, require a lot of energy on your part. Fossil fuels, they have that amount of energy stored in the chemical bonds of the material that they're made of, whether it's coal, oil, or natural gas. Burning those fossil fuels converts the energy that was required to form those bonds, and as it releases that energy as thermal energy. Okay. Our fossil fuel supply is obviously a limited thing. There's only so much oil or coal or natural gas on the planet. And other problems is that, recovering these fossil fuels, whether we're digging a well for trying to find oil or mining for coal, it is very disruptive to the ecosystems where that's occurring. Other problems would be like burning fossil fuels, causing pollution. It releases chemicals up into the atmosphere and creates things like photochemical smog. And then that in turn can cause respiratory problems. Those pollutants interact with water molecules in the air, and it makes acid rain. And then also it changes the chemistry of the soil and makes it so that certain things have a hard time surviving in the soil, certain plants. Now, nuclear energy is one that sometimes it's not a fossil fuel because it comes from radioactive materials in a mineral called uranite, and that the mineral, or I'm sorry, the substance or the element that we're trying to get out of the uranite is uranium, and that uranium gets used by a nuclear reactor in order to do atomic reactions or nuclear fission, and it creates heat. That heat then is used to boil water, and then that boiling water emits steam, and that steam is forced through a pipe, and it spins a turbine and makes a lot of electricity. Okay. Nuclear fission, I said nuclear fusion earlier, I meant fission, happens when you have these atoms of uranium. And if you were to strike an atom of uranium with a particle, okay, now this is a neutron off of some other atom. If you strike that with a neutron, it splits in two, okay? And then each one of those hits another uranium atom and splits that one in two. And then all three of those, they hit another one, they split that in two, okay? This is what we call an uncontrolled nuclear reaction. We have neutrons that collide with uranium atom. That uranium atom splits, it releases more neutrons, and those neutrons collide with more atomic nuclei of uranium, and then this goes very, very quickly, okay? I can't really show you guys that on here, but what happens then is if we can't control how fast those reactions or how fast those atoms are splitting, then we end up with an uncontrolled nuclear reaction, and then we can have meltdown of nuclear power plants. But there are things in place to prevent that from happening, like control rods and things like that, that will absorb those neutrons so that it controls how quickly those reactions take place. Okay, so there's some advantages of nuclear. It takes a very small amount of nuclear material or uranium, like a piece of uranium the size of a fingertip would be like the energy equivalent, I think, of 4,000 barrels of oil, something like that. Um, when you guys are in ninth grade, when we were studying this a little bit more, we'll watch a documentary that will sort of do a much better job explaining um, the amount of energy that we can get from nuclear materials rather than fossil fuels. Um, if properly managed, the nuclear power plants, they don't pollute the air, they don't pollute the soil, and they don't pollute the water. Um, in the documentary that we'll watch next year, it talks about individual could drink all of the water that's used to cool a nuclear reactor for an entire day, and you would get more radiation from eating a banana than you would from drinking all of that water. Okay, but there are obviously some disadvantages of nuclear. It can cause problems. Um, First of all, it's not a renewable. Okay, it's non-renewable. We can't replace it as fast as we use it. If it's not closely regulated, we can end up with uncontrolled nuclear reactions, which are very dangerous. And then we also have waste materials that are radioactive and will continue to be radioactive for thousands of years. And trying to figure out the best way to dispose of those has really become a challenge and prevented a lot of places from using nuclear power. Um, so in order to sort of manage or conserve our non-renewable energy, we try and use a combination of, some fossil fuels, some natural gas. I mean, natural gas is a fossil fuel. And then some of the more renewable sources like wind power, solar energy, things like that to help offset the amount of fossil fuels that we're using. Now, when we mine for things like coal, it's very disruptive to the landscape. And there's a process called reclamation that through the process of reclamation, that land is sort of reclaimed. Okay, so in the word reclamation, reclaimed and replanted with the vegetation that's native in that area, and it sort of helps to bring it back to its natural state. Okay, there are laws in every state and national laws that regulate how the mining operations can occur, and drilling practices if we're talking about drilling for oil. There's clean air acts that limit the amount of pollution that can go into the air, and there's obviously a lot of laws that help to protect people from nuclear emissions, I guess it would be, from a power plant that's not properly run. Okay, 18.2 is about renewable energy. So you can go ahead and pause it there, or if you're going to continue on, here we go. 18.2 is about renewable energy resources. Oh, we're not doing a pop quiz. What is going on here? Okay, sorry about that. I don't know what happened. All of a sudden, the PowerPoint just stopped. So we're back at it now. So we're talking about the renewable energy sources. Okay, so first one is solar energy. Obviously, we are pretty familiar with solar energy. Energy comes from the sun. There are solar cells on a solar panel that capture that energy, and then that light energy can be turned into electrical energy. There are materials inside the solar panels or chemical compounds inside of the solar panels that when they get heated up from the sun, chemical reactions start to occur, and that causes the flow of some electrons, and that's where the electricity comes from. That electricity, if it can be stored, if there's a way to store it, then it can be used later. But part of the problem is that as solar energy is created, if there's not something to use that energy right away, we have to have some sort of a storage facility for it. Right now, the only thing that we have that stores electricity is a battery, and our battery technology is not that great. You know, and they're quite expensive. So solar would be really great, but the problem is that if you can't use the energy right away, you better hope that you have some stored in a battery somewhere, especially like when the sun goes down, if you're watching a movie and all of a sudden your movie cuts out because you don't have electricity to operate the system anymore. Things are acting weird. Okay, so solar energy can be used to heat homes. Solar isn't just about creating electricity. Solar can be used to heat up water or other liquid compounds that get uh, pumped through pipes. Um, I've seen people that use a solar heater for like things like a swimming pool. Water gets pumped through the solar panel, and as that water is flowing through that, it's usually dark in color, and the water flows through, it warms up and goes back into the pool, and then eventually gets recirculated and heated up again. Essentially, that's the way it works. Other ways, there's like passive solar systems that, even a window in your house would be considered passive solar. Uh, Sunlight shines through the window and it warms up the things in your house. That's considered a passive solar system. Wind energy is the next. These are pretty straightforward. We have a wind turbine that's used to produce electricity, just like wind has been used for energy for a long, long time. Like sailboats would have used energy from the wind to help move their big ships. Um, it works a little bit, obviously, a bit differently in a wind turbine. As these turbines are spinning, it's connected to a shaft, and on the bottom of the shaft is a magnet that spins inside a coil of wire, and that's what creates electricity. We'll talk a lot more about that next year, at the beginning or towards the beginning of the school year, when we learn about electricity and how to make electricity. Um, Hydroelectric is the next one we'll talk about. Gravity makes water flow downhill. So if there's a way to capture that water as it's flowing, like water flows in a river because it's flowing downhill. If you put a dam on the river and then you channel the water into a tunnel, and that tunnel has got a turbine that spins because water is flowing through there. It's connected to a shaft, and that shaft is connected to a generator, which is a magnet that spins inside of a coil of wire. As it does that, it spins that magnet, and the spinning magnet inside of a coil of wire makes electrons or electric charges flow, and they flow out into a wire and then to the power company and then eventually to your house. There's a few different ways of doing hydroelectric. The one that we're most familiar with, obviously, is putting a dam on a river and then forcing the water to go through a tube or a tunnel where it's going to spin this turbine on its way out. Tidal power is another way that this happens. We know that the sun, earth, moon system causes the tides, and the tide comes in and then the tide goes out. And as it does that, we could use that to spin turbines, and those turbines again are connected to a shaft, and that shaft is spinning in a magnet inside a coil of wire, which is a generator, and that's creating electricity. Now, tidal power can be used in a couple different ways. As the tide makes the water come ashore, then some sort of a barrier comes up and blocks the water, and then forces it out through these little tunnels. And then as it's passing through those tunnels, it's spinning a turbine on the way through. Or you just put these big turbines out in the ocean, and as the water or the tide comes. The time has changed to 3 o'clock for the para meeting, the media center. 3 o'clock for the para meeting. As the tide comes in, it spins the turbine in one direction, and as the tide goes out, it spins it back in the other direction. That would be another way that that works. One really interesting one that I kind of like is what we call geothermal. Geothermal takes energy from inside the earth and uses it to do one of two things. Number one, it can be used to make electricity. And number two, it can be used to just heat things up. Now, let me go ahead once. Okay. One interesting thing, if you use geothermal, and stick with me on this for a second, you have these big pipes that get buried deep underground. And if you go anywhere more than about 10 feet underground, if you bury those pipes, the temperature there is probably going to be somewhere in the ballpark of about 60 degrees, probably 50 to 60 degrees. Okay. Now, if you think about that, during the winter time, when it's, say, minus 10 degrees outside, if you're pumping 60-degree water through the floor of your house, what is that going to do for your house? 60-degree water pumping through your house when it's minus 10 degrees outside. Well, that's going to help warm up your house, right? Now, let's think about the opposite of that. Now think about during the summertime. If you're pumping 60-degree water through the floor of your house and that is radiating out to the rest of your house, when it's 90 degrees outside, that 60-degree water pumping through pipes in your house is going to help to cool off your house. So what this does isn't necessarily saying that, oh, hey, you're not going to have a furnace or some sort of a heating system for your house or an air conditioning system for your house. But what it does suggest is that it does the brunt or most of the work of either cooling or heating your house, so that it makes your furnace and your air conditioner have to work less hard to bring the temperature to a comfortable level inside your house. I mean, nobody wants to live in a house that's 60 degrees during the wintertime. That would be awfully cold. And nobody wants to live in a house that's 60 degrees during the summertime either, because that would be too cold as well. Okay, so the next one is biomass. This is basically anything that we can use to burn, right? Things that we're living that we can burn, like wood scraps, grass clippings. I mean, even as much as like, cow manure. Or cow pies. There's a lot of places that were, 100 years ago were burning cow manure to heat their homes. A lot of third world countries will burn cow pies to cook food and things like that. I know it sounds kind of gross, but that's the reality of it. Other things that would be considered biomass would be like alcohols that we get from fermentation process, and that can be created by using just about any type of biomass. We can create ethanol with that. So obviously there's some advantages for using renewable resources, because the main thing is that we can the nature can reproduce those things pretty much as fast as we're using them. Yeah, if you cut down a tree, or a tree dies and you cut it down and burn it for heat in your house, it's going to take, 15, 20, maybe 30 years for that tree to grow back to the same size that it was. But that's a whole lot less time than the millions of years that we're talking about in regards to fossil fuels. Burning renewable or using renewable resources significantly reduces the pollution that enters the atmosphere and carbon dioxide emissions into the atmosphere as well. So there's also some disadvantages of renewable resources. Sometimes those things are expensive to make, like a wind turbine. It costs about $1 million, if I remember correctly. They are also disruptive to the ecosystem. I mean, there's no system that's perfectly harmonious with the earth, right? It takes resources to build a wind turbine, and the cost of the earth to mine the materials, to make the steel, to produce the wind turbines, and then the landscape that has to be adjusted and altered. You have to worry about migratory patterns of birds, and birds crash into these things. And, I've heard stories of ice or water vapor building up on the blades of the wind turbines. And if they start spinning too fast, these big chunks of ice will heave off and can travel very, very far distances, crash into houses and things like that. So it's not perfect either. The renewable resources tend to be less efficient than fossil fuels, meaning that the amount of energy that we get out of them isn't necessarily as much as the amount of energy that we could get out of an equivalent amount of fossil fuels. And obviously technology needs to be developed better in order for us to use some things, like earlier, a little bit ago, we talked about batteries and being able to store the electricity from solar panels. This is a massive hydroelectric dam, and you can see obviously the landscape is greatly altered by the presence of this dam, and ecosystems are disrupted. Now, if this is providing electricity for your home, maybe you're not quite so worried about the animals that might get killed or have their habitat disrupted by having a dam there. Solar panels are great, but the process of making solar panels, it is actually a fairly toxic process. So that's not a perfect system either. Wind turbines are great, but again, they have their drawbacks as well. If you put up a wind turbine near your house, A lot of people complain about the swishing sound, and there's a lot of reports of people having chronic migraines and other health problems if they live near wind turbines. I don't believe any of that has been scientifically proven yet. They're probably working on that and doing studies. Uh, One other thing that people that live near wind turbines complain about a lot is the flickering. So if you think about when the sun is going down, every time that blade is spinning around, you're going to get a flicker of light. Flicker, 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 flicker. So, and even if you have pretty heavy duty shades on your windows, you're still going to sense that flicker. And that, I think, is sort of disruptive to the human brain. Okay, 18.3 then is about land resources. I'll pause for just a second, and then we'll get going on 18.3. All right, land resources. So when we think about land resources, we're thinking about the stuff that the earth is providing for us, the natural resource, something from the earth that living things use to meet their needs. Now, maybe your needs is that you want to go fishing and you need water to do that. Okay, that would be considered a need. So the land itself is a resource. Cities make up such a small portion in comparison to the amount of land in the United States. Okay, most of the land in the United States that is inhabited is used for, or most of the land rather, is used for agriculture, grasslands, and forests. Obviously, there's mountains and things like that as well, but the majority of the land is agriculture, grasslands, and forests. So uses for the land are a lot of different things. It could be developed as pasture land for grazing cattle, crop land for growing crops, urban areas for developing and building houses and communities, special use. I'm assuming that would be like for commercial stuff, like all of the stuff that you would find in a city, sports arenas and golf courses and things like that. And then another large portion, 28 or almost 29% for forest or forested areas. There's a picture of a very large tree. Now imagine this forest, if someone said, hey, let's build some houses there, and they wanted to cut down these trees, that one's going to take them a little while. Minerals are one of the resources that we mine from the land. This is a big mine, and ores, if you recall back to one of our early chapters, I think chapter 2 or 3, something is considered an ore if you can mine it at a profit, so if you make money off it. And a lot of those minerals are we mine a lot of those minerals because they're helpful for us in our daily lives. Some of the non-metallic minerals would be like sand and gravel, gypsum, halite. Halite is the mineral, sodium chloride. Halite is the name of the mineral. The compound is sodium chloride, table salt. Those types of things are used in non-metal products. Gravel and sand, a lot of construction application for that. Metallic minerals are used for making metallic products, okay, like aluminum cans and aluminum for cars and refrigerators, things like that. Iron for steel, or for creating steel, and obviously tons of different uses for steel. Now, obviously there's advantages of using land resources. Soils and forests are pretty well available for us all, and they're easy to access. And then crops and trees are also considered renewable resources. Now, if we cut down an entire huge forest, that's going to take a long time for the forest to recoup and come back to where it was before it was cut down. But if you go through and you cut down particular trees to use for making lumber to build houses and things like that, that's a much more responsible and sustainable way of using those resources. Obviously, there's disadvantages. Deforestation happens when we're cutting down large swaths of forest so that we can have, or for whatever purpose it is for human activity. It destabilizes the soil, and then it causes those areas to be prone to soil erosion. It cuts down habitat for organisms. It intensifies global warming, because if you think about this, global warming is partly caused by an excess amount of carbon dioxide going into the atmosphere. So if we're cutting down organisms that are naturally doing photosynthesis, taking carbon dioxide out of the atmosphere, it seems a little counterproductive. It takes a long time to replace those ecosystems when we cut down an entire forest, right? And then pollution from mining and other mining operations cause the soil and the water to be polluted. So it helps if we recycle. I mean, we've been hearing since the time we were little kids that, oh, we should be recycling, we should recycle. And that's true, because if you think about all of the materials that we take from the earth, if we're able to recycle those, it cuts down quite a bit on the amount of resources from the earth that we have to go and try and add into our system or our society. Okay, so there's 4 sections. 18.4 is about air and water resources. I'll pause for a second, and then I'm going to get going. Okay, so using Earth's resources, it tends to make life easier. That's the whole idea behind technology. And technology, by definition, is something that we develop to make life a little easier or make a task a little bit easier. Could we survive without fossil fuels? Certainly we could. Would life be a little more challenging? Absolutely. I know we all like to ride in cars and, have our motorized toys and things like that. If that stuff went away, it would be uncomfortable, right? Air and water are 2 of the resources that we really cannot live without. Obviously, we know that living things need to have water. Every living thing on Earth requires water. Nothing can live without it. That's why we look for, when we look for life on other planets and things like that, we look for the existence of water, because we know that living things on Earth have to have water. Most things can only survive for just a few minutes if they don't have air. So these are obviously 2 really important resources that the Earth provides for us, okay? Water plays an important part of every function of your body, just about. Controls your body temperature. It helps oxygen to get in and out of your blood cells or to attach to your blood cells. Your blood itself is 83% water, and water helps you to digest food, and it helps to turn oxygen into, energy molecules. This comes as no surprise. Polluted air is definitely harmful. We call that polluted air photochemical smog. It's a brownish color haze in the atmosphere that happens when nitrogen or nitrogen compounds combine with other pollutants in the air, and they react with sunlight. And that creates a hazardous environment for especially people that already have compromised respiratory systems like asthma. The smog will irritate the tissues inside of your lungs. If you're an individual that has asthma, it increases the chances of having asthma attacks. And then sometimes if the weather conditions in the atmosphere are right, it traps that smog really close to Earth's surface, and it can remain that way for many days. And so you think about that, people are just breathing in that smog for days and days and days. Acid rain is another one. Pollution that goes up into the atmosphere mixes with water vapors in the atmosphere, and it turns the water droplets slightly acidic. And when that water eventually condenses, or those water vapors eventually condense and they fall down to the earth as raindrops, number one, it's destructive to the plants, specifically, or more specifically, pine trees. It'll strip the needles off of pine trees. But it also enters the water system and it acidifies the lakes to an extent, which is bad for the organisms that live there. It pollutes the soil, and it kills not just pine trees, but other trees and plants as well. Forest fires and volcanic eruptions also pollute the air. Volcanic eruptions put a tremendous amount of compounds into the air that wouldn't normally have been there. Now, this is a natural process that happens on Earth, so it's one that's very, very, it's impossible to get away from. And then forest fires are obviously something that they happen, and as the trees are in a forest are burning, it releases carbon dioxide into the atmosphere. In regards to water, less than 1% of the water on Earth is what we call available fresh water, meaning that it could be used by the living things to, drink or whatever. Um, Most of it is frozen. In fact, we know from the last chapter that 97% of the fresh water on Earth is frozen in glaciers or ice sheets. But obviously, we need to have water, right? Because that's what we drink and we need it to live. We use it for making electricity, a lot of household activities like cooking food, flushing toilets, washing clothes, taking showers, transportation, a lot of goods and shipped to us over the oceans. And then obviously recreation, because at some point in time, everybody just wants to go fishing, water skiing, fishing, surfing, whatever it happens to be. There tends to be a lot of recreation that is based on water. So, if we want to maintain and protect these resources we have, there are active steps that need to be taken in order for that to happen. So when we think about managing our air and our water resources, we think about legislation or laws that have been passed to help us protect those resources in the environment. The U.S. Clean Air Act 1970 limited the amount of pollutants that could be in the air. So industries that are polluting are limited by how much pollutants they can actually put into the air. The U.S. Clean Water Act reduced the amount of water pollution that can happen. The Safe Drinking Water Act protects water supplies or drinking water supplies. And then we can all do our own individual part to help with this. We can use less energy. Okay. If you don't need to have the lights on, turn the lights off. If you don't need to run to the store in the car, take the bike, walk, go rollerblading, whatever it happens to be. Recycling the materials that we already have rather than creating more plastic, and plastic comes from oil, which is a fossil fuel. Rather than, drilling for more oil, how about we recycle the plastic that we already have on the planet, or recycle the aluminum or the steel or whatever it happens to be. And then disposing things properly, or hazardous materials being disposed of properly, is very important to prevent the pollution of the land. Okay, that's it for this chapter. You guys keep up to speed on the worksheets, and we'll have the test on it sometime soon. I hope this video finds you guys all healthy and doing all right. I know that this situation that we're in is not ideal. But we're just doing the best we can. All right, so hang in there. We'll be through this soon enough. Take care.